Earth observation is important when it comes to policy decisions. It's enabled us to give very detailed pictures of how the oceans are changing in terms of warming over the past 20-30 years. We've seen a quarter of a degree increase in temperature. But it's also important in terms of trying to understand things like pollution impacts in coastal zones. Whilst we can't always get the fine resolution we want, it allows us to get a baseline on what's there in advance of an incident like an oil spill or a major chemical spill. When it comes to policy in the coastal zone, we're looking at things like storm damage, rising sea levels, the impact on societies, particularly those living near to the coasts, not just in Europe, but across the world. And if you consider places like Bangladesh, the last time they had a 25 centimetre rise in sea levels as a result of a storm surge, over 200,000 people lost their lives. So this isn't just about policy, it's about saving human lives. And trying to get the bigger picture from Earth observation is one of the tools in the toolbox that allows the scientists to do their job.
One of the things that we are starting to do increasingly with Earth observation data is to use a variety of different Earth observation data to help us address very specific scientific issues. One of those issues that we're looking at the moment is the study of storm surges through a programme that ESA has sponsored called eSurge. And what we're doing within the eSurge project is to bring together a range of different remote sensing data sets for particular storm surge events and show how they improve our understanding of those events, particularly when linked with ocean modelling that will allow us to forecast events in the future. We have several example case studies where we have very complete data sets. The cyclone Sidr, which hit Bangladesh in 2007, is one example. It was a hugely destructive storm, caused flooding across large areas of Bangladesh. There were up to 10,000 people died during that particular event. But there's virtually no in situ monitoring of the events in that area. There isn't the infrastructure to provide it. But through the eSurge project, we have wind data from scatterometers that allow us to show how the storm surge was being pushed up against the coast. We have coastal altimetry, which is a development of the standard products to give us more information closer to the coast, that gives us an idea of what height the surge actually reached when it got to the coast. We have some inundation mapping products that allow us to see how far the water actually extended onto the land and the areas that were flooded. We have ocean colour, which allows us to see the longer term effects on the biology of the ocean caused by the storm surge and the sediment that's lifted and redistributed by the storm surge passing through. So there's a whole range of different Earth observation products that are all being brought together to give us a much better picture of what the storm surge looked like. Those can go through to improve the forecasts that we have for storm surges in the future.